I've recently been building a feature to help e-commerce teams turn supplier catalogues into product data they can actually review and publish. This appeared as if it was a perfect use for AI. It could read messy files, find useful additional information, and return structured products. When I ran it the first time, the result was good enough that I genuinely thought I'd cracked it. Then I ran it against another file from the same supplier, and the system solved the problem completely differently. This exposed an issue with the way I was thinking about the problem, which meant I had to throw the original architecture away and think about the product from a different angle. So this isn't a story about finding a better model or writing a better prompt. It's about changing the job that I was getting AI to do. Once I changed that one assumption, this system became easier to explain, easier to test, more predictable to operate, and potentially much cheaper to run repeatedly. Supplier data is invariably messy. One supplier sends you a spreadsheet, another one sends a CSV, and someone else sends a PDF or a collection of images. Even when two files contain similar information, their columns, terminology, and structure can be completely different. Product teams don't want to have to think about any of that. They just want clean product data in a consistent shape, ready to review and eventually publish to whichever destination they're trying to populate. So the input can vary wildly, but the output needs to be dependable. The obvious design was to put AI in the middle of everything. Give it the supplier files, prompt it to extract the products, enrich missing information from appropriate sources, transform everything into the destination format, validate the result, and return a catalogue ready for review. It was very easy architecture to explain. Messy files go in, magic happens, and clean products come out. It seems simple enough that it might actually work. The frustrating thing is that it did work. Well, initially anyway. So this is a view of what I ended up with on the review page. The product appeared on the left and can be compared with products that already exist in the destination. The fields that needed attention are brought together for ease of review. The first import read the source, tracked down official sources of additional information, built structured products, and returned them to the application. It looked like exactly the feature that I wanted to build. At this point, I genuinely thought the difficult part was over. The problem appeared when importing another catalogue from the same supplier. The shape of the work hadn't changed, it was the same supplier, same shape of source data, and the same intended destination. But from the model's point of view, this was a completely new run, so it reasoned through the task again. The result still looked correct, but the fields were interpreted differently. Enrichment choices varied, and the products were assembled in slightly different ways. This was a serious problem for the product, as although the result was reasonable, there is no way that the e-commerce team will want to review changes on every new upload, even if nothing substantial had changed. If the work was provided in the same shape, then the system needed to behave consistently. Reasonable isn't the same thing as repeatable. I realised that the model was doing exactly what I'd asked it to do, solve every import as a new problem. But the product didn't need a fresh solution every time. It needed a reusable way of solving the same shaped problem, so I threw the first architecture away. This was the moment that the penny dropped. I'd been treating AI as the thing that performed the whole workflow. The more responsibility I gave it, the more prompts, retries, validation rules, and edge cases started accumulating around it. The better question wasn't, how do I make the model produce the same answer every time? It was, how do I turn the useful reasoning from the first run into something the system can execute consistently? The answer wasn't to remove the AI completely. It was to give it a more precise responsibility. Instead of asking AI to process every import, I decided to ask it to build the reusable transformation that processed the supplier's data. That distinction mattered. Now, I'm not suggesting that this is the correct approach for every problem, but it certainly worked here. If the task is genuinely different every time, fresh reasoning may be exactly what you need. But for repeated same-shaped work, if the reasoning can be converted into a reusable engineering asset, then that may be the more robust solution. The new sequence starts with an example supplier file. An AI worker examines the source and writes the transformation needed to turn it into the product shape Foundry expects. That transformation is code. It can be inspected, tested against known examples, versioned, improved, and saved. An isolated runner executes the transformation, and the result is submitted through an API to Foundry using a stable contract. When another file arrives in the same shape, the system doesn't need to rediscover the approach. It can reuse the saved transformation. The AI becomes involved again only when the source changes enough to require refinement. The operational boundary is important. Foundry queues a job, and a separate worker environment owns the AI and code execution concerns. The generated transformation runs inside a restricted environment, and only a validated result is allowed back into the application through the API. That means long-running jobs, retries, model selection, and generated code are not random hidden logic inside the public application. They can be scaled and changed independently. Isolation doesn't automatically make generated code safe, but it does create a controlled place where permissions, network access, time limits, resource limits, validation, and observation can be enforced. The first run creates transformation version 1. Run 2 executes that code. Run 10 can execute the same code and inherit the same behaviour. If the supplier changes their export format, that doesn't mean the system is stuck forever. The transformation can be tested against a new example, refined and saved as version 2. Later runs then use that known version. This means that what works on run 1 can still work on run 100, without reopening the full reasoning problem every time. Before the change, AI solved every run. That meant fresh variation, repeated model usage, and behaviour that was harder to test and debug. The application also needed to understand more of the AI-specific workflow. After the change, the useful result of the first run became a reusable tool. The transformation had known behaviour, could be versioned and tested, and returned data through a stable API contract. It still needs engineering, it needs tests, validation, monitoring, and a way to evolve, but those are familiar software engineering problems, rather than fresh AI reasoning problem on every import. The breakthrough was architectural rather than a better prompt. There was an unexpected economic benefit as well. In the original design, every import required another model run. In the redesigned system, most of the model work happens when the transformation is created or refined. Routine imports can execute the save code without asking the model to rediscover the same solution. I can't really put a savings percentage on this because these blocks are conceptual pattern, not measured production data. There are still infrastructure and execution costs, but repeated model usage is reduced, which makes the operating cost more predictable and should make subsequent imports considerably cheaper. There is an obvious warning here. AI writes code cannot mean run anything the model gives us. Generated code should be treated as untrusted. The runner needs limited permissions and only the files, network access, and resources required for the job. The output must match a defined schema before the API accepts it. Known examples should test the transformation, and every version should be traceable so failures can be understood and rolled forward safely. These controls aren't an optional extra. They're part of the architecture. The queue and isolated worker give us a place to enforce them. Once this was done, it was clear that AI wasn't the product. It was another worker. Foundry remained responsible for orchestration, review, validation, and synchronization. The worker had a clear responsibility: create or refine a reusable transformation, execute it inside a controlled boundary, and return a valid result. Once AI had a clear job, the rest of the architecture became much easier to reason about. I don't think this pattern applies to every AI task. Sometimes a task is genuinely new, and fresh reasoning is the value. But when the problem repeats in the same shape, it is worth asking if it's actually a different question. I don't think this pattern applies to every AI task. Sometimes the task is genuinely new, and fresh reasoning is the value. But when the problem repeats in the same shape, it is worth asking if it's actually a different question. Should AI solve this again, or build the thing that solves it? For this particular workflow, turning the first useful reasoning into reusable software made the system easier to test, operate and trust. If you're building something similar, I'd be interested to know where you draw the boundary between AI reasoning and repeatable software. Let me know in the comments.